This research paper, titled Ensemble Bayesian Inference, Leveraging Small Language Models to Achieve LLM-level Accuracy in Profile Matching Tasks, is authored by Haru-Tata Sato, Fuka Matsuzaki, and Jun-Ichiro Takahashi from the Department of Data Science at ICE Factory Corporation in Tokyo, Japan. The study investigates how ensembles of small language models can match the performance of large language models in tasks like profile matching, by introducing a new method called Ensemble Bayesian Inference. At its core, the paper proposes using Bayesian estimation to combine the outputs from multiple small language models, or SLMs, to overcome the limitations of any single model. This approach allows these lighter, less resource-intensive models to achieve accuracy levels comparable to proprietary large language models, or LLMs, which are typically more powerful but computationally expensive. The experiments described in the paper focus on diverse tasks, including aptitude assessments and consumer profile analysis, conducted in both Japanese and English. For instance, they tested how well the ensemble method performs in matching personal profiles based on evaluation texts, which often contain noisy or misleading information. The results show that Ensemble Bayesian Inference, or EBI, is highly effective, with some surprising findings. In particular, the researchers found that including models with negative lift values, meaning models that individually perform worse than random chance, can actually improve the overall ensemble's accuracy. This highlights how diversity in model predictions can lead to better outcomes. The paper also examines how EBI works across different languages, demonstrating its robustness in multilingual settings. These insights open up new possibilities for building high-performance AI systems without needing massive computational resources, making it easier to utilize even lower-performing open-source models effectively. To provide some context, the introduction draws from related fields like medical diagnosis and psychology. For example, studies have shown that models like GPT-4 can sometimes outperform human physicians in diagnostics, while in other cases, they perform on par or fall short. In psychology, AI has been tested for tasks involving decision-making, cognition, and even creative ideation, where it often matches or exceeds human novelty but struggles with feasibility. The paper points out challenges in these experiments, such as human cognitive biases, subjective evaluations, and variability in judgments, which make fair comparisons difficult. Against this backdrop, the authors focus on a specific judgment task: person identification through text-based evaluations. Imagine you have two sets of comments about the same group of people, and the goal is to match them accurately. These texts might include vague or contradictory statements, making the task prone to errors. To tackle this, the paper introduces EBI as a way to incorporate probabilistic judgment from Bayesian inference, combined with elements of human-like variability and confidence levels. Bayesian inference itself is a statistical method that updates probabilities based on new evidence, essentially mimicking how we might revise beliefs with more information. In EBI, this is extended to an ensemble framework, where multiple SLMs provide their judgments, and these are aggregated using Bayesian principles. This accounts for the variability in generative AI outputs, much like human judgment can fluctuate, and turns it into an advantage for more reliable results. The paper builds on existing research in areas like LLM performance evaluation, ensemble learning, and the use of open-source LLMs. It emphasizes the novelty of EBI by showing how it not only improves accuracy but also addresses practical concerns, such as computational costs and latency. In real-world applications, where speed and efficiency are critical, this method allows for high-volume processing on faster hardware, helping to close the gap with proprietary LLMs. One key aspect explored is the role of judgment diversity. While traditional ensemble methods for generative AI aim to boost accuracy by combining models, this study specifically investigates whether varying predictions from lightweight, open-source SLMs can enhance performance. The findings suggest that even models with individually lower accuracy can contribute positively when integrated through EBI, thanks to the way Bayesian estimation weighs their inputs. In their experiments, the authors analyzed various scenarios, including how EBI handles noisy data in profile matching. For example, in aptitude assessments, the method was tested on tasks that require inferring personal traits from descriptions, and in consumer profile analysis, it involved matching user behaviors or preferences. The results across Japanese and English datasets showed consistent improvements, underscoring the method's versatility. The paper also discusses the broader implications. By leveraging SLMs in ensembles, organizations with limited resources can create sophisticated AI systems without relying on expensive proprietary models. This could democratize access to advanced AI capabilities, especially in fields like personalized marketing, psychological profiling, or even medical support tools. To ensure transparency, the authors have made their codes and data available on GitHub, allowing others to replicate and build upon their work. Overall, this research advances our understanding of how to combine probabilistic methods with ensemble techniques, offering a promising pathway for achieving high-accuracy AI inferences in challenging, real-world tasks.